Welcome back. We're going to do a quick lesson today just on properties of exponents. We're basically just going to review some things that you've seen before that we may not have used really a lot this year, but they're really helpful in order to take derivatives, which we're going to start tomorrow. So we're just going to take a day to review some of these properties. And as we start to do derivatives, we'll also review other ways of simplifying or rewriting functions. So in calculus, the easiest functions to differentiate, and differentiate just means to find the derivative of. Okay, so that's your verb for finding the derivative of, to differentiate, are power functions. Now, a power function is always written in the form of a constant times x to a power. Okay, and this constant could be any number. It could be a radical, it could be positive, it could be negative, it could be a fraction, and same thing with n. It could be any number. Positive, negative, zero, fraction, radical, all right, as long as it's a constant. And then your base would be x. So it's going to save us time if we can use simplifying techniques to rewrite a function as the sum or difference of powers. Okay, so that's all we're going to review today is just how to rewrite functions so that they're the sum or difference of powers, if possible. It's not always possible, and what I find a lot in the power rule for derivatives is that some students try to use techniques that aren't allowed. All right, they try to simplify a function into something that it doesn't equal. All right, so you have to make sure when you're simplifying it, you're getting an equal function. Okay, so let's look at some of these examples. So this first one we're going to look at, this is written as a product. Okay, so x minus 2 times x plus 7. All right, this is the product of two functions, but we can easily get rid of the parentheses by foiling. All right, distributing, combining like terms. And then when we FOIL it out, we end up with this. Now, this is written as the sum or difference of powers. And how do you know if something's a power? Well, if you can identify k and you can identify n, then it's a power. So this first term, k would be 1, n is 2. This next term, k would be 5, n is 1. And this next term, k would be negative 14, n would be 0. So one of the properties that we've done before is that anything to the 0 power is 1, which is why there's no x here. So this is now written at the sum and difference of powers, and this is going to be much easier to deal with in a calculus situation than this function. So taking the time to rewrite it is going to be beneficial to us. The next example, we've got the square root of 5x cubed, and this is in parentheses, so the entire thing is inside the square root. So this is not technically written as a power because this entire function is inside the radical. But since they're being multiplied, we're allowed to take the square root of each term. All right, so we're going to split it up. And remember, square root as a fraction or as an exponent would be to the 1/2 power. So we've got our square root of 5, which we can just leave it as square root. And then the x to the third, all right, we're taking the square root of that, but to rewrite it as an exponent, all right, we'd have to write it to the 3/2. And again, this is review from course 2 material. All right, just going over that because we haven't really used it yet this year. So if you can identify k and n, it's a power. So k is square root of 5, n is 3/2. And then we've got our base x. The next example, we've got a power function or sum or difference of powers on top, but then we're dividing it by 2x squared. So we need to be able to get rid of this big fraction bar if possible. Well, since there's only a single term on the bottom, we're allowed to divide each term by 2x squared. All right, it's the same thing we would do if we had this in parentheses and we were multiplying by 2x squared. We would distribute. We're going to distribute this division because it's only a single term. Now, when you divide powers, the rule is to subtract the exponents. And in 2 slides from now, you'll see all the different properties that we've been using. Okay, so this first term has to get divided by 2x squared, then the second term has to get divided by 2x squared, and the third term. So when we write it out, the first term, we get k is 1/2. All right, because the 1 out in front and the 2 here doesn't reduce, so we just have 1/2. And x cubed over x squared is x to the 1. So k is 1/2, n is 1. The next term when we divide it, negative 4 divided by 2 is negative 2. And the x squared over x squared cancels. So in this case, k is negative 2, and the n, the exponent, is 0. Plus, now we've got 7/2, so that's going to be our k value. X squared on the bottom, since we want to write it as a power, right? And when we look at powers, x has to be on top. There's no x on the bottom. To move that up, we make the exponent negative. So we get 7/2 times x to the negative 2. All Right? So again, this isn't something that we like to deal with before, but in calculus, it's going to be much easier to deal with this function. And then for our fourth one on this one, okay, so this one we only have a single term on top and the bottom. So when we're rewriting the exponent here, right, cube root of x to the fourth, that would be x to the 4/3, but then we want to move it up, so we have to make it a negative exponent. So this is how we'd rewrite it as a power. All right, so the 15 is your k, then you've got n is negative 4/3. Okay, so you can't have x's on the bottom when you're trying to rewrite it as the sum or difference of powers, but you can have negative exponents. All right, that's going to be okay. So let's look at a few more examples and then we'll put up the rules. So this next example, so now we've got a cubic here and we're squaring it. So it says rewrite it as the sum or difference of powers if possible. So what we're not allowed to do, and what happens sometimes in calculus, is people want to distribute the squared, and you're not allowed to do that when you have subtraction or addition. But since this is a whole number exponent, whole number exponents just mean repeated multiplication. So 2x cubed minus 5 squared means we're multiplying by itself twice. So that we can just FOIL out. And that will give us this, where we have our k x to the n. So k is 4, n is 6, k is negative 20, n is 3, k is 25, n is 0. And this one could be easy folded out. As this number increases, this would be more difficult to do. Okay, when we have our cubic, fourth degree, when we did our Pascal's triangle and the binomial theorem, we saw that it's difficult to expand out binomials when the exponent gets larger and larger. But for a squared, it's pretty easy. In the next example, we've got the cube root of x to the fourth plus 3, and this whole thing is inside of our cube root. Now, what we're not allowed to do, same thing up here, we can't distribute the cube root to both terms because this is addition. The only thing we could do to rewrite this problem is we could rewrite this as an exponent, but the x to the fourth plus 3 is still in parentheses, so it can't be written as the sum or difference of powers, right? Because again, you're not allowed to distribute the 1/3, and this is not a whole number exponent that we could just expand. So this is the only thing we could do. All right, so don't try to do more. This one, it's not possible. All right, and in calculus, we'll talk about that a lot. If a function can be rewritten, sometimes we'll rewrite it. If it can't, all right, we might just leave it like this. And then for our third example, we've got another division one, but this one, there's one term on top and there's 3 terms on the bottom. So again, we're not allowed to split up denominators. That's something that we've never been able to do. If you did negative 2 over x squared plus negative 2 over 4x minus 2 over negative 9, it's not the same function as this. Therefore, it's not equal. All right? This equal sign is really important. Whatever you put on this side has to be the same as this function. And if it's not, then you're making a mistake. So this one, we can't split it up, but we could rewrite it with a negative exponent. The only thing we could do is this. All right, we've got our negative 2. And if we wanted to move this entire denominator up, we could do it to the power of negative 1. But since we're not allowed to distribute exponents, this is as far as we can go. So even this one cannot be written as the sum or difference of powers. So sometimes this is as much as we could do. So the properties that we've been using, just if you want to have a list of them, copy them down in your notebook so that you have them if you don't remember. All right, the radical rules. All right, if you've got the nth root of b, you can rewrite it as b to the 1 over n. And remember, if this is square root, they don't write the 2 here, but that implies that n is 2. All right, square root of b would be b to the 1/2. And now if you have a power inside, all right, or even a power on the outside, the exponent is the numerator and the root is the denominator. All right, so you can rewrite it as this power. And then we have our other properties, that you've used with exponents before. This is the one that we were talking about before. When you have a product to a power, you can distribute the exponent, but not when you have a sum or a difference. And same thing down here. If you have a quotient of a power, you can distribute the power to the top and bottom, but again, no addition or subtraction. Exponents on the bottom, you can bring them up, writing them with a negative sign. Anything to the 0 is 1. When you divide 2 powers, you have to subtract the exponents, top minus bottom. All right. And when you have a power to a power, all right, that's when you have to multiply them. If you're multiplying 2 power functions, you just add them. So again, this is all review, but it's something that will come up a lot throughout a calculus course. And it's not something we're going to reteach, but it's a good idea to look at it now before we really start to get into finding derivatives using our rules, okay, which is what we're going to do tomorrow. All right. So it's a quick worksheet to do, just similar problems like this. It says, if possible, rewrite. If not, just say it's not possible. This one's going to be due tomorrow, okay, because it's a very quick review, and we're going to start derivative power rules tomorrow.